you've seen me do lots of fabrication, brackets, fiberglass, I don't know, fitting windscreens, fitting the engine and all that. But all of that is kind of, I wouldn't say finished, because it's no road testing happened yet. But surely anything after all that must be just mere details. So I'm going to park all that stuff until we've got the last proper element of this Invader Restomod story going, finished, and that is the engine. But so we now need to move on to computer stuff, and here we have a laptop. The very first stage of this: does the laptop speak to the ECU? Evidence of some pre-work. Does it speak to the ECU or not? That I actually did a couple of weeks ago. Let's go back to the beginning. So as you can possibly see in red down here, the ECU is not currently speaking to the laptop. So the first stage is to switch the ECU on, switch the ignition on, and I have taken the precaution of disconnecting the fuel pumps, because we just don't need that at the moment. We're at a more basic stage. So the first thing I'm going to do is switch on the ignition. Connect. And lovely, my little red thing has gone to a little green thing. I should say really that this whole exercise is something which is a little bit beyond anything I've done before. Although, I shall just diverge for a moment, although this one here has in fact got an ECU as well. This one is a Zetec engine, and it uses an Omex standalone management system, and I've lost track exactly how long ago I put this in. Originally this car ran on carburetors, and then quite a while ago now I changed to fuel injection and I got the Omex ECU, but I didn't do any tuning on it whatsoever. It came to me from, I think I ordered it from Burton Engineering in Ilford, and I asked them to put on it a map suitable for a Zetec engine, which they did, and it works amazingly well, so much so that I've never bothered tuning it at all, ever. It's never been on a rolling road, it just seems to work brilliantly, so I've never actually had to get in amongst the setup of the ECU at all. So that's why I'm saying that this task here is something which I've never really done before. I mean, I know all the principles, and I've read up a lot about it, and I know what's going on, but at the same time I've never actually done it. I've never actually put in an aftermarket ECU and set it up. So we'll see how far we get with that. And step 0.1, does the ECU speak to the computer? Well, that fortunately has proved to be a success. And I will say at this point, because the connection between the laptop is via a USB cable, at the other end, which is down in the footwell somewhere, it's what they call a 9-pin D-type connector, which is a multi-pin connector about yay big with 9 pins in it. Yeah, so not exactly a USB, but it does the same job. Now, one of the things which I've come across this before actually. One of the things I did find out fairly quickly, because I think there's three or four wires. Three, I think you need out of the 9 to make the what's called a serial connection from the computer to the ECU to make that work. And you would think you'd put your transmit wire onto your transmit pin and receive wire onto your receive pin. No! That's not what you do. You put your transmit wire onto your receive pin and your receive wire onto your transmit pin. Of course you do. Now think about it, that makes perfect sense because you're transmitting to something and receiving from something. So there's a bit of logic there. But anyway, so after swapping around a couple of wires, that got this part working. So this part is now working and we can actually see into the ECU, and here it is, it's connected to the ME360. So that's the very 0.1 stage. The next stage is to discover if the ECU is talking to the engine. Now, one of the major items which is required to do that, of course, is the crank sensor. And the crank sensor, for those that might not know, and I guess there's very few people on this that won't know, but let's assume there might be a couple. So the crank shaft goes round, obviously, and quite likely on the pulley at the end it goes round, or it might be built into the engine further in. The crank sensor looks at the crank as it goes round, and the crank and detects where it is in its cycle as it goes round. And the way they do that is by having a pattern of a thing that looks a bit like a cog, really, which detects exactly where the crank is in its cycle. And because it needs to be quite accurate, and there's, rather than sort of 6 cog teeth, as you might imagine, with a 6-cylinder engine, it could easily be 30 or 60 or something like that. So that's how it detects where the crank is. But it also needs to, apart from work out RPM, it also needs to know whereabouts in the cycle the crank actually is. And so for that, there's various different methods, but very often the cog pattern that is on the crank or on the crank pulley will have a tooth or two missing. So the magnetic detectors, they're usually magnetic, which might detect a sort of square wave going up and down like this, will then see, oh, there's one missing. So up and down, up and up and up and down, then nothing, 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 up and down, up, and so on. And that's how it works out whether where the crank is in relation to top dead centre. But so far, anyway, I don't know exactly what the pattern, and there's many different ones. The software comes with a setup for quite a few different engines, but not the AJ30, because we don't know what the pattern is. We need to find out. I watched a little video which Motorsport Electronics put up, and we're now going to have a go at finding out the tooth pattern. As I said, to many of you this will be teaching Granny to suck eggs, but for others of you, perhaps more who have been interested in the fabrication side, shall we say, of all this, rather than on the engine side, then you may not know so much about that. Up here we have RPMs, and up here we have a status window saying it's not synchronised. So let's see what happens when you spin it over. So we got, what does it say there? 882 crank IRQs. Yeah, I can't remember what IRQ stands for. Interrupt something. It's an electronics term I do recognise. But there was no RPMs and it wasn't synced. Now, picking up on the video that I watched from Motorsport Electronics, I'm going to go and have a look at the diagnostics. Now, this is the thing that you saw before, but I'm going to go back on it. So we're running from a diagnostics panel up here. We're going to start what I already have started, and then spin it over. This is kind of like a built-in oscilloscope, which is nice actually, because I thought I might even have to get my actual oscilloscope out, and that would have been a bit of a nuisance. Anyway, let's try and see what it sees. Right, hopefully that's enough. Right, so at least you did see one kind of square wave thing. So let's try and see what the pattern looks like. So we're now zooming out on the trace. So this pattern proves that, well, first of all, it proves that the crank sensor is being detected at all, which at least shows that my wiring is correct. But what's this pattern then? I'll move you over slightly. Now it certainly looks like a pattern that is regular, but it appears to have got a couple of gaps in it. Can you see? 1, 2 gaps where there isn't a spike or isn't a pulse. It looks to me like there's two pulses missing, but I can't see how to do what he did. I'll come back in a moment. So I'm going to right click at the first pulse that after the gap. I'm going to go across to at the end past the first, or the sorry, past the gap, so it's one complete cycle. So what do we have? Right click. So we have rising edges 36, falling edges 35. That's what it says here. So it's 36. There would be plus 2 more. 30. Is it 37? Or maybe I picked up the next pulse. So if I click differently, no, okay. Let's try that again. Make sure I click in the right place this time. Okay, so having discussed with Motorsport Electronics, I'm just going to try one more demo, but I think actually my problem is likely to do with the camshafts. Off camera, I've done some more testing with the Mighty software from Motorsport Electronics to see if I can get a signal coming through from the cams. And no, I can't get a signal coming through from the cams. I think it was a bit strange that you would get nothing at all. So even with one wire you might see some noise, but nothing whatsoever. So I'm going to go back to basics and see if I have a connection between the camshaft and the ECU inside. And there's a couple of joints. There's a plug, I think there's another plug. There could be as many as 3 plugs involved, shall we say. And on top of that, of course, we've got the possibility that something is just not wired up properly. So let's see what we can find out. Alright, so I've plugged the meter probe in the back of the plug where there's a rubber grommet. And hopefully that's making contact with the wire. So what I need to do now is go around the other side and connect the other side of the multimeter through to the where the ME360 ECU is meant to be. You probably can't hear this. The meter is beeping very high pitch. Tell me I do have a connection. So the plot thickens. So after quite a bit more time actually, during which I discovered wiring faults. Of course there was wiring faults. And even when I checked for wiring faults, there were still more wiring faults. In fact, I'll mention this one in particular. Having inserted pins into the multi-way plug and tested them with a meter by putting from the ECU. Of course you can't test inside the ECU, so I put some wires into the ECU plug, put a meter on, and I was able to measure the resistance through to the camshaft sensors, and yet I was not getting any camshaft signal. Cue a couple of days of work, quite honestly. Okay, not full-time work, but a couple of days elapsed, and conversation made me have a look at the wiring again, and guess what? The pins weren't fully inserted into the plug. So even though I tested with a piece of wire pushed up inside the plug hole, of course that went in a lot further than the pin of the ECU itself does. Now I just wanted to illustrate the problem I had with my ECU plug, where the wires, which I thought were fully inserted, weren't. So this is what you normally see, this plastic cover, and here is the one from the other side. It just clips on or clips off, and what you can see here are the sort of front end of the connector, the electrical connector, which is the part that you crimp on the wires and push through from the back. Now that's all fine as long as you can be totally sure that the connector has actually emerged at the front, as it were. Otherwise, when you push your ECU on, see the pins there, it ain't necessarily making contact. So this is how I managed to get probes, connectivity probes into the plugs that have got female pins on, as these great big probe, the actual pins from the meter are too fat, so solid wire twisted on quite tightly and push the bare end in, which is much better with solid wire than it is with stranded, because it doesn't fray. If you got as far as this, thanks very much for watching, and in case you haven't already, please do consider subscribing. That would be really encouraging for me. So catch you on the next one.